Hello everyone, welcome to my channel Nerdy Coder. If you're the first time seeing my video, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. In this video, I'm going to show you how to create a solid API contract and enforce it in a REST API. I will also show you how to include a Swagger UI in your Express.js REST API. Swagger UI is very helpful for testing and visualizing your OpenAPI document. If you remember in my last video, I talked about the MVC pattern in REST API. I'm going to implement this API contract portion with Node.js, Express.js, and TypeScript. If you want to learn more about applying MVC pattern to REST API, please check out my last video. We'll first create an OpenAPI document, and then use the OpenAPI document to generate TypeScript types. The TypeScript types will help us create REST API in TypeScript to conform with the API contract. We'll then add Swagger UI to our REST API so that our API user can easily see what they expect in the request and response. We will also implement logic to validate request and response automatically based on the OpenAPI document. This way, we don't have to create custom validation functions. By starting with creating an OpenAPI document, we can achieve these outcomes very easily. If you haven't seen a Swagger UI before, this is how it typically looks like. It lists all the endpoints defined in the OpenAPI document. It shows the details about each endpoint's request and response. You can also make API calls directly from the Swagger UI. Swagger UI is very helpful for development and for others to know how to use our REST API. Let's get started. I'm starting with the REST API I created from my previous video. If you want to learn more about REST API or how to build a REST API, please check out my previous video. I'm going to first install all the dependencies I need in this video. For runtime dependencies, I will need Swagger UI Express and Express OpenAPI Validator. For development dependencies, I will need Swagger JSDoc, OpenAPI TypeScript, Swagger UI Express types, and the copy file package. Swagger JSDoc allows me to write OpenAPI document in JSDoc commands. This allows me to write the API contract next to where I define the routes and endpoints in the code. This dependency also allows me to combine fragments of OpenAPI document into a single file. If you don't use this, you can always write OpenAPI document directly as YAML or JSON files. The OpenAPI TypeScript package allows me to create TypeScript types from OpenAPI document. The Swagger UI Express package allows me to add Swagger UI to Express.js endpoint. The Express OpenAPI Validator allows me to automatically validate the HTTP request and response based on the OpenAPI document. For the copy files package, I will explain it later. I'm going to start by creating the OpenAPI document using Swagger JSDoc. Swagger JSDoc takes two inputs. The first input is a definition file. This file usually contains the OpenAPI version and other metadata of the OpenAPI document. We could also include any valid elements in the OpenAPI specification. The second input is a list of files which could be YAML, JSON, or files containing JSDoc comments. Regardless of what format the definition or other input files are, they need to be written according to the OpenAPI specification. I'm going to use the OpenAPI document I created in my other video for this calculator API. If you want to learn more about OpenAPI specification and how to write OpenAPI documents, please check out my other videos on OpenAPI. I'm going to put all these files under the routes folder. This way, all the OpenAPI definitions are located close to where the paths are defined in Express.js. I will first create a definition.yaml file. This file will have the OpenAPI version. I'm going to use version 3.0.3. It will also include the info, tags, and external documentation sessions. The tags session has two tags, the health tag for the health check endpoint and the calculator tag for the set of calculator endpoints. These are all valid sessions and schemas under the OpenAPI specification 3.0. Next, I will create a health.yaml file. This file contains all the components related to the health endpoint. It contains a health status schema to represent the response of the health check endpoint. It has two properties, status and timestamp. We will then create error.yaml file. This file contains all the components related to error responses from this API. It has an error model schema and responses for internal server error and not found error. I will add a path definition for the health check endpoint, where above where I define the health check endpoint in the Express.js router. This health check endpoint could return a health status object with a 200 status code, or a response representing internal server error with a 500 status code. These are valid syntax in OpenAPI specification. In order for Swagger.js to read them in a JavaScript or TypeScript file, we have to do two things. The first thing is to wrap the definition in js.command. The second thing is to add a Swagger or OpenAPI tag in the command. We can try to create a complete OpenAPI document from what we have written so far. To create an OpenAPI document from the YAML files and the js.commands in the TypeScript files, we have to run this command in the terminal. Swagger-js.-d. D stands for the definition file. In this case, this is the definition.yaml file we created. I will also provide a list of the TypeScript files with the js.commands, as well as all the YAML files which are not the definition file. I will also specify the output file where the final OpenAPI document will be saved. I'm going to save it under a folder called schemas with a file name of openapi.json. We have to run this command with npx. And before we run it, we have to create a folder named schema under source. And after you run the command, openapi.json file should be created. It is a complete OpenAPI document in JSON format. Next, I will quickly create OpenAPI definitions for calculator endpoints. We'll recreate the output file for the OpenAPI document with the health check and all calculator endpoints. Since we're going to use this command every time we make changes to the API definition, we can save this command in the script section of the package.json file. Once we have the OpenAPI document, we can create TypeScript types very easily using the OpenAPI TypeScript package. We can then use the TypeScript types to help us update our REST API to conform with the API contract. To create TypeScript types from the OpenAPI document, we can run this command in the terminal. npx openapi-typescript. The first argument is the source OpenAPI document. We also specify the output file. I will save the output file under the folder schemas with a file name of index.d.ts. You can name this file however you like. We'll save this command in the scripts section of the package.json file so that we don't have to type it every time. You can see a new file has been created under the schemas folder. It contains the interface for all paths, components, and operations defined in the OpenAPI document. The types we'll be using will be from the components interface. We'll create types for the data transfer object from these schemas. We have types for the health response DTO, calculator command DTO, calculator result DTO, and error DTO for the error response. We'll create these types in the types folder. The health response DTO will reference the types from the component schema's health status interface. The calculator command DTO will reference the types from the component schema's calculator command interface. And the calculated results DTO will reference the types from the calculated results interface. The error DTO will reference the component schema's error model. And then we'll output the types in the index.ts file. We'll then use these TypeScript types to help us update the API's responses to make sure that they conform with the API contract. We'll start with the health check endpoint. The first argument to this callback function is the request object. The request type is a generic type. The first argument to this generic type is the path parameters, which we don't have any. And the second argument is the response body. In this case, it will be the health response DTO. Once we update it, you see that the TypeScript compiler has shown errors in the responses. We update our response to conform with the health response DTO. Next, I will update the calculator endpoints. I will start with the getAllCalculations endpoint. This endpoint will return an array of calculator results DTO. I will also do a little bit of refactoring here. I will create a set of mock data and save it into a variable. This way, other endpoints can reuse the same mock data. In this getAllCalculations endpoint, we simply return the mock data. Now I will update the getCalculationById endpoint. The request object has an attribute of ID in the path parameter, and the type of path parameter is always a string. It returns a calculator result DTO. I'm going to first locate the calculation result from the mock data by a matching ID. If I cannot find the result, I will throw a new not found error. We don't have a not found error defined, so I'm going to create one. I'm going to first create a class called HTTP error. This class will have a status code, and it extends the error class. And then I'll create a not found error subclass extending the HTTP error class. This not found error has a status code of 404. Now I'll go back to the getCalculationById endpoint, update the code, and then return the result. Now I will update the deleteCalculationById endpoint. Similar to the getCalculationById endpoint, the request object has an attribute of ID in the path parameter. I first locate the index of the calculation results from the mock data by a matching ID. If I cannot find an index, then I will throw a not found error. If I can find the index, then I will remove that from the mock data, and then respond with a status code of 204. I will first update the create calculation endpoint. The request object does not have a path parameter. The response is a calculator result DTO, and the request body is a calculator command DTO. Results could be number or undefined. And I will add a message variable, which is a string or undefined. For the division case, if the operand 2 is 0, I will set a message of division by 0. Otherwise, I will calculate the result. I will remove the default case since the operand must be one of the 4 cases. And then I will set a new calculation. But now I use the ID of 4. I will add the new calculation to the mock data, and then send back the new calculation with a status code of 201. Now I'll go back and update the updateCalculationById endpoint. The request object has a path parameter of ID. The response is a calculator without DTO. And the request body is a calculator command DTO. I'll first check if the calculation result exists with a matching ID. If not, I will throw a not found error. If the calculation result exists, then I will make the calculation based on the calculator command. The code is similar to the create calculation endpoint, so I copy the code from the create calculation endpoint and update here. And then I will update the mock data and then send back to update the calculation. Lastly, I will update the array middleware to make sure that the array response is in the shape of the error DTO. Now, I will start up the Express.js server to make sure all endpoints still works. The next thing I want to do in this video is to be able to validate all the requests based on the OpenAPI document. We can do this very easily with the library Express OpenAPI Validator. This library allows us to create a validator middleware for us to use in the Express.js application. I put this middleware in a file called validator.ts in the middlewares folder. We'll first import the library Express OpenAPI Validator as OpenAPI Validator. We can create a validator middleware with OpenAPI Validator.middleware. This function takes the options object. In the API specs field, we'll specify the path of the OpenAPI document. We'll set validate requests to true. We can also choose to validate the responses in the OpenAPI document itself. I will then export to the index.ts file, and then go back to app.ts and add the middleware in the Express.js application. Since we have the validator middleware created based on the OpenAPI document, the custom validation functions we created for the calculator endpoints becomes redundant. So we can remove them. If you run the Express.js server and try to make a request to the API, it's going to cause an error. It will say the Express.js server is not able to locate the OpenAPI document. The reason for this is that when the TypeScript transpiler transpile the TypeScript files into JavaScript files and save them into the dist folder, it does not copy any JSON files. So the OpenAPI document does not exist in the dist folder. To fix that, we can manually copy the files over to the dist folder. I'm going to use the copy files library to help me to do it easily. I will use this command npx copy files -u and then the number 1 and then the path to the source files and then the path to the destination folder. This command will copy the JSON files under the schemas folder to the dist folder and maintaining the same folder structure. I will also save this command into the script section of the package.json file. If you start a development server now and test out the endpoints, it should work now. You can also test out the validation functions by providing an invalid request. If you ever need to update your OpenAPI definitions, you have to run the command to create the OpenAPI document, the command to create TypeScript types, and then the command to copy the OpenAPI document JSON file to the dist folder. As you can imagine, this could become quite troublesome. I'm going to create a few scripts to help me automate this task. Before I start a development server, I'm going to first run the commands to create the OpenAPI document and TypeScript types, and then copy the files over to the dist folder. I'm adding a script named schemas, combining these two commands. And then I'll update the dev script as follows. When the development server is running, I will have Node monitors for changes in the routes folder. If there are changes, I will rerun these commands. To do it, I will create a nodemon.json file. This is a configuration file for nodemon. In the events session in this file, when nodemon detects changes and restarts, it will run this command. This command means that if there are changes in the routes folder, I will run the schemas and copy file scripts. I will also tell nodemon to monitor additional files tabs, including TS and YAML files. If you make any changes to the OpenAPI definition, the OpenAPI document files in the DIST folder will be updated automatically. Lastly, I will add a Swagger UI to our Express.js server using the OpenAPI document. I will serve the Swagger UI in another route, so I will create a separate router for that. I will import the router from Express and create a new router. I will then import the Swagger UI library as well as our OpenAPI document. If you see an error when importing the JSON file, you need to set resolve JSON module to true in the tsconfig.json file. To serve the Swagger UI, I will type router.use / swaggerui.serve and then router.get / swaggerui.setup. It takes an argument of the OpenAPI document. If you want to serve the OpenAPI JSON document in your API, you can do something like this. I will then export the router in the index.ts file. And then go back to the app.ts file and add the router under the path API docs. I will also update the OpenAPI validator to ignore any requests coming to the API docs path. This ignore path field takes a regular expression. Now, I will start up the development server. In the browser, I can access the Swagger UI in the API docs path. If you decided to serve your OpenAPI JSON file, you can also access the OpenAPI JSON files. This is the end of this video. I've shown you how to create a solid API contract using OpenAPI. With an OpenAPI document, you can generate TypeScript types to help you implement the API. You can also easily validate requests and responses without having to write custom validation functions. I'll also show you how to add a Swagger UI to Express.js application from an OpenAPI document. This is the video I wanted to share with you today. If you like this video and find this video helpful, please give me a like and subscribe and share this video with others. This will give me more motivation to create new videos for you. Thank you for your support. Goodbye and see you in the next video.